Hi, I want to talk about what happens when we have opposing traveling waves. Two traveling waves that have exactly the same amplitude, same wavelength, same frequency, but they happen to be traveling in opposite directions. So our two waves are written as follows. One is y1 as a function of space and time is equal to our amplitude A times the sine of our wave number k times x minus our angular frequency omega times time. And wave 2 then, as a function of x and t, would be A times the sine of kx plus omega t. Remember, opposite signs mean we're in the plus x direction. The same sign means we're in the minus x direction. Well, if I wanted to sum those two together, it turns out there's a trig identity that I can make use of to clean up the form of this just a little bit. So if you have the sine of a sum, the sine of a plus b or the sine of a minus b, that could be written out as the sine of a cosine of b plus or minus the cosine of a times the sine of b. So I could rewrite the sum of my waves as my total amplitude hanging out in front, sine of kx cosine of omega t minus the cosine of kx times the sine of omega t plus the sine of kx cosine of omega t plus the cosine of kx sine of omega t. Those terms on the very end and the first middle are the same. They cancel out. And this term and that term are both the same. So I get a factor of 2 here when they sum together. So the sum of my two waves would be equal to 2 times the amplitude times the sine of kx and the cosine of omega t. The spatial dependence of my wave and the time dependence of my wave separate. So instead of calling these traveling waves, we call them standing waves. And it would look like a wave has just stopped on that wave carrier and is just kind of oscillating up and down in place. Now, if we were to use something like a string, and then we were to put boundary conditions on that string, say, hold down each one of those ends, that ends up producing a discrete set of wave number values k based on the length of the string itself. And those standing waves make up the basis of not only musical instruments, but this finds its way into quantum mechanics as well. Thanks for watching.